have different types of relationships inside this relationship concept, and we will look at what are those kinds of relationships we have. So these are the three relationships we have inside complete relationship concept. The first one is many to many. The second one is one to many, and the third one is many to one. Many to many relationships, they are created and the referential integrity is set to some record match. This is a default connection whenever you drag some tables onto your data source. These default settings are actually a safe choice and provide the most to lot of flexibility from your data source. This default setting supports full outer joins. Many to many is completely a full outer join and optimize queries by aggregating data table before forming joins during analysis. So all the columns and row data from all the tables will be available for your analysis when you select many to many. So in this case scenario, what you're seeing right now, the book table is connected to order, edition, and ratings. So the book table to dimension is actually a many to one scenario. That means one author can write so many books. One author can have so many books. So in the book scenario, each book has some author, and that author can have many different books in this books table. That's why it is actually a many to one concept. From books to edition is actually one to many. So it has one book, but it can have so many editions per one book. We can have different editions, like just like Tableau, we have different versions. One book have different versions or editions. So in this scenario, there is one to many concept. One book with different editions. What is the book to ratings is also the same. One book and all the people can give different ratings to that book. So this one is a one to many scenario. The ratings concept will have too many ratings and they can all relate to one book, and that connection will be one to many. And as we already discussed, many to many is a complete outer join. It will bring all the related things in the first table, sorry, all the rows from the first table and all the rows from the second table. These are the different kinds of different types of relationships we have inside the relationship concept, and we call it as uniqueness or referential integrity. So the new terminology for uniqueness Tableau used is cardinality. The cardinality is actually termed as the uniqueness of that row or of that data. And referential integrity is like the matching records. Whatever matching records it has, they are calling it as referential integrity. And these are the main two things for all the performance options you get inside the relationship concept. These settings help actually Tableau optimize the queries during analysis by all the settings. In this relationships, we have settings inside the relationships like from one to one or many to many. So whenever you edit on a relationship and click on the performance options, you get these options inside, and the default relationship whenever you drag a table onto the canvas, the default relationship is many to many. So this is a full outer join. This default is actually a full outer join, and this will connect all the rows from the first and the second, all the rows from the second. That means you will get this entirely two different tables. And you can actually change the columns also. You can give multiple columns or a single column in the case scenarios according to your requirement. As we already discussed, the first table is a root table, and whatever column you're connecting on should have the same data type. These are the some clauses we will get in relationships, and when you click on the performance options, you will get to see whatever we spoke about the cardinality and the referential integrity. So cardinality is uniqueness, that means the row uniqueness, in this case many to many. Differential integrity is a mapping point, like whenever you use these two tables inside your visualizations, this differential integrity will play a part, and the default option for differential integrity is set to same some records match. In relationships, we have a concept called smart aggregations and its types. What are the smart aggregations and what are the things in relationships we will see about the smart aggregations? So, whenever you use a relationship concept for your data source, Tableau brings in the right data from the right tables at a right aggregation, handling all the level of detail for you. A data source with this relationships acts like a custom data source for each and every biz. Relationships can actually help you in three different ways. You have less upfront data preparation. That means Tableau actually combines only the relevant tables at the time of analysis, right? So it will actually preserve the level of detail. There won't be any pre-aggregation in the custom SQL or your data views. The second one would be more use cases for data source. This multi-table logical model, what you have in this relationship, you can preserve all the detailed records from multiple fact tables into a single data source. Whenever you have the need of connecting the data source again and again and again, like we discussed already, this relationship will save us a great time whenever you're using that kind of requirement. And the third one is it will give us a great results, greater trust in results. When you join, while joins can filter out data, relationships actually preserves all the measures. Now, important values like money will never go missing. Like when you use joins, there can be cases where some of the your rows might disappear because of the unmapped values. And unlike joins, relationship won't develop your data by duplicating them according to the level of detail. We have this concept of 8 R's of relationship semantics in Tableau. So Tableau needs rules to follow the semantics and determine how to query your data at the backend. So relationships have two types of this semantic behavior. The first one is smart aggregations and the second one is contextual joins. Smart aggregations is it will act automatically, measures are automatically aggregated to the level of detail of their pre-joined source table. This actually differs from joins where actually measures forget their source and adapt the level of detail of the post-join table. That means um, even before joining, the level of detail will be aggregated according to the table, but not according to the post-join table, whatever you get as an output, that as a small join. Contextual joins is unmatched values are handled individually per vis. So a single relationship simultaneously supports all types of joins. That means you can actually join the different join based upon your visualization because it brings up all the data, right? With this contextual joins, a join type is determined based upon the combinations of measures and dimensions inside that particular visualization and their source tables. So the figure you're seeing right now, this is called 8 R's of the relationship semantics with all the smart aggregations which are coming up in green and the contextual joins coming up in purple or pink, whatever you want to call it as. And we are seeing three different shapes, eclipse for measure, square for dimensions, and we have curved edges for both of them. According to the boxes, you can define whether they are measures or dimensions or whether they're acting as in both. So I will just explain the theoretical content right now of what is what, and later in the practical content, we will see how this smart aggregations will perform in whenever you're doing some practical content. Okay, we have 8 R's. The first one, resolve, replicate, relevant, retain, remain, recover, remove, represent, and the final thing, relationships, which is all combined to the relationship. So these are the 8 R's which is related to the relationships, and these are acted according to the requirement whenever you're doing the data analysis. The first one is resolve. This is a smart aggregation. Resolve aggregations to measures native level of detail. That means the aggregations will happen to the native level of detail of that row. It won't aggregate based upon the level of detail when you join, right? Like only go inside your view, then only it will bring up your whatever join you need. But whenever you're bringing up the tables on your canvas, it is aggregated based upon the native level of detail. That is one kind of smart aggregation we have, and that is totally related to the measures. The second one we have is replicate. Replicate measures across a lower level of details in the WIS only. That means this is also related to the measure. Replicate measures according to the WIS, and it will go to the depth of lower level of the details. That means it will go to the depth of row. That is replicating measures according to the smart join. And you might understand it better whenever we're doing with an example, but right now we're going up with the basic definition of what is what. The third one is relevant. It comes for the dimensions, and this is a contextual join. Relevant dimensions domains are shown across tables. So whatever relevant domains are there, it will be shown across the tables. Retain all measures. This is a contextual join, and this is measures. That means it will actually bring up everything from all the tables. So the measure values, whatever you have inside, will bring up everything. Remain. Full domains remain for dimensions from a single table. This is related to the dimensions, and all your dimensions will remain whenever you're bringing up from a single table. All the full domain will remain there. Represent unmatched measures as zero. If you see here, this is an actually important thing. Represent measures, and whenever there is an unmapped value, it will be counted as zero. It will not bring up a null, but it will be counted as a zero. Remove unmatched values with filters. You can actually remove whatever unmapped values you have with the filter, and it comes with both measures and also dimensions, and this is a contextual join. The last one we have is recover unmatched dimensions with measures. You can recover unmatched dimensions with measures. This comes with the contextual join, and you can work with both measures and dimensions. And as we also already saw the theoretical content, let's go inside Tableau and understand whatever it does when we are doing a practical thing. Let's start with the types of relationships first and see how these types of relationships works whenever we work with a relationship. So this is our main page. Whatever we have built before, this is our main page. We have a bookshop, a data set. So if you are in a scenario where you aren't sure what you want to choose inside this type of relationship, use this recommended default settings which are set by Tableau. Using this default is safe, and it will automatically generate correct aggregations and joins whenever you're doing your data analysis. And if you don't know the cardinality or referential integrity, you don't need to change the settings. You can go ahead with the default values, whatever Tableau has set for you. But if you know the shape of your data, you can optionally change these settings to represent uniqueness and matching between these records of these two tables. If you just click on it, so then if you go to the performance options, you get this cardinality and referential integrity based upon these two values. So we will just go into deeper depth of what is this cardinality and what options do we have inside this cardinality. This determines cardinality determines if Tableau aggregates table data before or after automatically joining the data during the analysis. It is mostly related to the joining like many to many and one to one, etc. And you have these options to change in a drop down over here. Select many if the field values aren't unique. And if you just know that in your column you have duplicates, like you can in this case you can have a book, and you can have the book name again. So if you aren't sure about if my column is unique or not, just go with the many and select one only if your field values are unique. During analysis, the relevant data will be joined before aggregation, and setting this option will optimize queries in your workbook. Whenever the field values in the relationships are unique, it will optimize your queries as well. But make sure whenever you're selecting one option over here, make sure that your column or whatever field you're using inside must be unique. And if you're selecting one and if your field is not unique, it can result in a duplicate aggregation values, and it will actually mess up with your visualizations. And referential integrity determines the type of join used to get the dimension values for the measures during analysis. So everything, whatever joins you do and whatever combinations you do is based upon the level of detail, right? The level of detail is always based upon the dimensions. And whenever the level of detail comes up in the scenario, even if your measures are actually coming up with the type of join, and select this some records match if some values in the field doesn't have a match in the other table. That means you know that okay, it might not have a matching value in the other table. I'm not sure if I have the exact all values matching up with the other table. Then you during analysis, what Tableau does is it uses the outer joins to get the dimension values for a measure, and all the measures values will be shown in the view. Even if it has unmapped values, all the measure values will be shown over there. And you will have to select only this other option where you have all records match if the values in the fields are guaranteed that you have a match in the other table, and you are very sure that okay, this will have a match, then you can actually select this all records match. This setting generates fewer and simple joins. Whenever you're using your analysis and optimization, this will actually generate fewer and simple joins. But you might see inconsistent results during analysis because unmapped values will be removed, or they will be missed. If there are like unmapped values in your table, they might be missed because you are sure that everything will match. That's why you're actually selecting all records match. And in this case scenario, when you use this all records match, this unmatched values, whatever you have inside your tables, will be missing. So my suggestion, instead of thinking of all the settings in your performance option, like do I have to go this, do I have to go there, rather than go with okay, I don't know, I'm not sure, just pick up what Tableau is thinking about my tables. Just go with the default settings, and if you're sure that your tables values are unique, select one. Or if you're sure that each record in one table matches one or the more records in other tables, select all records match. Otherwise, you can 100% go with the default settings, whatever Tableau picks up for you. So we are using this terms cardinality and differential integrity and again, right? So if you want to understand into deeper depth of what cardinality refers is, this we already said that this is the uniqueness of the data, and uniqueness of a data contained in a field or a combination of the fields. Whenever you join the data, the uniqueness of the complete entire row. When the tables you want to analyze contain many rows of data, queries can be slow, and this actually affects the overall performance of the data source. So it is recommended to choose a method of combining data based upon the cardinality of related columns between the tables. Low cardinality, when the related columns have a lot of repeated data. For example, a table of products might contain a category column that contains three values of furniture, office supplies, and technology. So inside this furniture, office supplies, and technology, this is a higher level of aggregation, right? Category is actually higher level of aggregation. In this case, you will have a low cardinality, it means low uniqueness, because the aggregation is at higher level and you have a deeper level of data inside. Your category is the highest level of detail what you have. High cardinality is like a table called orders might contain the order ID column, which can be unique. It will go to unique value for every order of that product. This is a high cardinality, means higher uniqueness. The order ID can come up with a higher uniqueness than the category value, because category has only three values: furniture, office supplies, and technology. And this is related to so many things in your data, which will result in low cardinality. When you go with the uniqueness of a column, let's say order ID, which has its alphanumeric content inside, and it refers to so many rows inside your data, that can result your higher cardinality value. Referential integrity means that one table will always have a matching row in the other table. For example, the sales table will always have a matching row in the product table, right? Products will be sold and you will get your sales. So all the sales content is actually mapped up with the product table. That's all about the referential integrity. This is all related to the mapping of the records with the other table. So we spoke more about how duplication will happen whenever we use joins. And let's take an example of okay, I wanted to have a join inside the book. I wanted to join award and info of the book. If the book got an award, I mean, if the author got an award, or I want to look at what is the info of the book. Let's say, okay. So what happens right now is book is mapped with award and info. And whatever measure values we have inside, like whatever numerical content we have inside, will be joined, and this book measure values will just give us a flat table. In this case scenario, book is joined with award and book is also joined with info, and we will get a complete one table whenever we use a joins, right? We will get complete one table, and the measure values will be aggregated based upon the join, and it will be aggregated on to join itself, and we will get the values over here already. And whenever we come outside, so this book has a join inside, and this join we are mapping up with the some other tables. So the measure values are already aggregated inside based upon the book. When we do this to relate it to other tables, the already aggregated values inside this book one will create a duplicated measure value for this book and info. So to avoid this kind of duplication, you must have to use relationships without using a join. So this flat table will already have the aggregated level of detail for all the measure values. And whenever you use this flat table with the other relationships, there can be a duplication of your measure values. That's why what you need to do is just open and remove this. This is a case where we can get, this is a possible case where we can get the duplicated measure values inside your data. That's why in this case scenarios, for measuring for the duplication of the measure values in this case scenario, it's always better to use this whatever tables you have in the relationships rather than the joining inside the table. As book and the award will have this one to many kind of relationship, because one book and they will have info and one to many kind of relationship. One book can get many awards. That's why it's actually the relationship of one to many, and also the measure values will be already aggregated inside the join. And whenever you combine this again to the to other tables, this might create a duplication in the measure values. So moving on to our smart aggregations, I wanted to show you how this different kinds of R's will act and what is the actual meaning of the 8 R's we have. And to do this, I'll just bring up all the tables into our view, and let's check how Tableau will work with all these tables on the view. I'm just bringing up everything onto the view. Okay, it by default Tableau recognizes the relationship between the book and award, and it actually sat between book and award with the connection. Okay, I added checkout, and checkout also added up with, I'm just doing a double click, and Tableau will automatically recognize what is the unique column with the other tables, and it will set us up with the connection as well. And what else we have? We have ratings, and we have, okay, we added ratings. Okay, ratings is added to the book, and yeah, we have series. I'm just double clicking everything. I did not see the data also. Okay, we got something in this. Let's check that. Okay, we do not have a common class. Okay, let's add info here because we have a common class for info and book, and inside the info we have a common class for series, then we can add that there. Okay, okay, let's create. I've just made a join for info to the book, and by this we can get a relationship for book and series. So, we got the series ID here from the info, and we got the series ID here. Okay, that is mapped. And the last one, publisher. Okay, publisher actually went up with edition. Tableau recognized that okay that there is a join for publisher there. So I'm just right clicking. I did not even see the common clause. I just right clicked, and yeah, we have the sales data also, and we have for 4 quarters. Okay, what we'll do is okay, let's union all the data, and okay, just drag them because sales all the quarters will be the same. I'm just making upon all the quarters into one single table. Union will make this as all the sales per that year, let's say the 4 quarters, and we have data for all the 4 quarters right now as this is union. And the sales, if you see here, the union symbol will be looking like this, and the join symbol will be looking like a Venn diagram. Okay, we got everything, and whatever we have inside the sheet, we got everything. So first we will discuss about is remain. So remain actually tells us that the dimensions which comes from a single table, if all the dimensions we have are coming from a single table, Tableau shows all the values in that domain, even if no matches exist in the other measure table. Let's see how that look like. Okay, I'm just going with the book count and author. Okay, let's say author. Okay, we have so many names. One second. Okay, let's combine the first name and the last name because the first names can be the same for different persons or vice versa. The last name can be the same for different persons. We don't want to show duplicates. That's why I'm just combining this for a unique value in the last name. So this one will create a unique value for us or the name. Okay, so this one will be unique, and we got this many values. And if you see here, so the dimension we took is from author table and the measure value we took is from the book table. If all our dimensions are coming from one table and the measure value is coming from a different table, all our measures will actually remain like that. If you see here, it is showing the measure values for all the others right there. But if you see here to the end of the line, we are not seeing some values for the some others. That means the dimension column is bringing up all the data, but the measures are only showing up to the mapped values. That means the dimensions will remain if you have this from one particular table, if all your dimensions in that specific view are coming from one particular table. Even if you take the measure from other tables, whatever dimension data you have in that table will be shown here. And if you switch on the labels, okay, mark labels, if you see here, this will show a 0. So Tableau will only pulls the data from tables that are relevant for the visualization. In this scenario, we are pulling the table columns from book and also the author. So this one will generate a result combining these two tables, the dimension from the author value, author table, and the measure from the book table. So we took a dimension from the author table, that is only one dimension. So all our dimensions, because we only took one dimensions in this case scenario, all our dimensions is coming from the book table. And all the dimensions will be remaining like that, but whatever the measure value is coming from the other one, and wherever we do not have a mapped value, this will show like this. But you can see the dimension values coming up here. This is called remain. The next one, next R value we'll be talking about is representing. So for the representing, I will be taking the dimension from author. Let's take the author name again, and let's also take the book count. Okay, we got author name and book count. Let's place our book count in here, columns. Okay, to sort the data. We had the same example before, right? So what I will do is I will take one more measure from the, let's take it from checkouts. So I'll just take number of checkouts, and this gave me a sum of checkouts. So adding some of the checkouts into your Wiz shows a null measure value. Let's sort it here also. If you see here, we have 8 null measure values for authors with no books. So that means whatever null values you're seeing right now in the checkouts, that means they doesn't have any books. The author doesn't have any book in that particular checkout. So unlike the count aggregation, which automatically represents nulls as zeros, so the count expression actually showed a zero, right? In this case scenario, this one is actually showing nulls. That means it did not find any data over there. And if you want to see a zero, and it means there is no data, like create a general option which will bring up everything over there, and just click on OK. And this one will actually show the labels here with all the unmapped values, and wrapping the sum with the gerund functions actually shows all the nulls with zeros. That it will represents it like that. That's why we just use a gerund function over there. This means that the representing unmatched measures as zero means it did not find any data over there, and this will actually show us as nulls in here, and we can represent them as zeros, and these are known as unmatched measures. This is telling that okay, this order doesn't have a checkout at all in the other table, and this one will throw you a null from your measure values. And if you want to show them as zeros, you can always show them as zeros by wrapping up with Z. And this is the represent concept, and basically, count will show us zeros, and like unlike the count, the sum will show us nulls. That's why we just add. I wanted to see what are those ones where author doesn't have any books, and this is how you represent whenever there is a null value coming up, and when there is a no match to the other table. So moving on, the next R we are going to discuss about is relevant. So relevant domains are shown for dimensions across values. We will see what that is actually. So, what happens? What it is saying that relevant domains are shown for dimensions across tables. That means what happens if you only use dimensions in your tables. Let's take the dimension of author name from the author table, and if you want to see who won the award, let's go and see. Okay, we just have to take up the award, who won the award. If you see the data, Tableau is only showing the other names who won the award. It actually excluded all the other people who did not have any award in that database. This is actually called relevant, which is I mean, alternately, we can take it as relevant data only. Only the mapping content, whatever other name has the award, will only be shown. All the others will be gone. You will be only seeing the data who won the award. This is what relevant one is when you're using dimensions across the tables, and Tableau will only show the data which is relevant to that particular dimension. If you're like using two dimensions from two different tables, this is the combination of data you get in your output. So next we are going to discuss about is retained. So retained is unmatched measure values or always retains. I mean, unlike like a join relationship always retain the unmatched measure values. Let's see how that looks like. I'm just taking the author name again, and let's also see what are the awards, and this will only show us only the awards which have the award data, right? And what if we just pick up some measure value? Okay, let's pick up the measure value from book. And if you see here, we used a measure from the other table. Adding the count of books measures shows all the books by authors and award. Since some books did not win or they did not have any award data, you see here in the award name we are seeing nulls. This is not excluding the data. This will bring up all the measure values. All the measure values are reading, even if it is unmatched. Unlike the join, it will bring up all the unmatched measure values also. So the golden rule of relationships that will allow you to generate any join type is that all records from the measure tables are retained. This is as cool as that you can actually show whatever is mapped and also show whatever is not mapped. So we spoke about a retain of measure values, right? The next value of R is recovering. So recovering is recovering unmatched values with measures. Right now you're seeing the same example of retain where it showed the authors where they do not have any award. But if you see here, even for a null, it is actually showing the same value of book of count. What if we want to show all the unmatched values also? Let's take some measure to that particular table, to that particular order name, and I'm just keeping that into the detail, and I'm detail in the sense I'm just including that into the view. If you see here, if in the before scenario, we are seeing some content for the null values, right? If you see here, there is no content. If you see here that there are some authors with no award and with no books will be shown here, and it will show a zero over here because our data is too much, it is not fitting up, that's why we're not seeing zero. But if you just pick up, well, this will show a zero over there even if the author has no award name with no book. And if you see here, there is some null value with a book coming up. That means they actually have a book, but they did not win an award. So this is how you can recover some values, unmatched values, where in this case scenario, our author name who doesn't have the books also into the view, and we just dragged some measure value from the author and it showed us who doesn't have the books also. This is called recovering of unmapped values. Since Tableau always retain all the measure values, you can recover any unmatched dimensions by just adding a measure from that particular. So the next R we are going to discuss about is a remove. Remove is actually remove unmatched values with filters. Okay, for that I'll just bring up. I'll just bring up the title of the book, and that it will select actually the book table, and I will be going with the. Okay, let's take the measure value from rating, and I will say okay, rating onto my columns. Let's take the average rating of the book because each book will have different ratings, and the different ratings will sum up with a different value. Let's take the average of each book. Let's sort the data as well. And we have, let's also differentiate them with, okay, so yeah, some colors. So right now we have two nulls in data. That means we have also the data which is not mapped with the rating content. It can be the case scenario You may be wondering why you're getting this null values, because the title for that book did not have any ratings. So you just filter it out. You can actually filter the null values, filter the count of ratings to be greater than equal to 1. For that, what we can do is, let's take, so what I will do right now is, okay, I will just go with the ratings table and I will say show filter for the ratings table. I will just add this to the filter and I will say at least 1. So what Tableau will do is it will remove the nulls from your the rating value. And you may be wondering, okay, why can't we just exclude the null ratings? So filtering the count of ratings like this will remove the books without any ratings. But reviews, but it preserves the reviews that may lack a rating. That means the unmapped content will be nulls, and the ratings with a zero value can be having a data, but they did not have a rating there. Excluding null would remove both of them, and if you want to preserve the reviews which doesn't have any rating, it can be zero sometimes. You want to preserve them, you can go with this scenario saying that okay, just make it as a greater than 1. In this case, you can remove all the unmatched values with the filters and relationships. Actually postpone choosing a join type until you're doing any analysis with the visualization. So applying this filter is equivalent to setting a rightful join and purposefully dropping the books without the ratings, right? So not specifying a join type from the table start also enables more flexible analysis. So this is how you can actually remove the unmatched values by using a filter. So the last thing we are going to discuss is resolve and replicate. So aggregations resolve to the measures native level of detail, and measures are duplicated across lower level of details in the WIS only. So if you look at the book one, now each book will have only one author, right? One book can have many ratings and it can have many editions. And reviews are given for a book, but not an edition. So the same rating can be counted across for multiple editions. So because the rating is given to book but not the edition of the book, that's why this all the ratings can be given to each edition. The same rating will go to the each edition. This means there is effectively many to many relationships between the ratings and the editions. So we will just take an example of, we'll take the author name and we will go with edition. So let's take edition over here and we will see the ratings. So ratings is, we will take the rating. So we will take count of ratings because we have to see what is the rating for each book, right? And we already have the format also, which means the edition cover. It will show the values of the books for all the editions. Okay, let's take this. Let's sort our data. And if you see here, so this lady who is Bianca Thompson will have a highest rating of 5,559. Okay, and this is the further rating of that hardcover. It can be the scenario where it is the sum of the all the other three for the mass market. It can be the scenario that of that as well. Let's look at how the totals are going to be for this case. Okay, let's look at the totals. Let's take the subtotals for this. So if you see here, Banker Thompson, since all of our books were published in hardcover, while only some were published in the other formats, the number of reviews per hardcover publications is equal to the total number of reviews per her books. In this case scenario, this is actually totaling all the other things and giving the rating for the hardcover. This is the entire ratings she got. So using joins, ratings would be replicated across editions in the data source. If you use the same case scenario by doing a join, what happens is this one, the count of ratings per author would show the number of ratings multiplied by the number of editions per each book. So this each one, but it will be counted as each book, even if it is an edition. For each book, for each edition, the number will be multiplied. So in this case scenario, what relationship is doing that? It is actually summing up according to the what we call cardinality, uniqueness, the type of join. In this case scenario, it is actually many to many. The replication only occurs in the specific context of a measure. This will be split by dimensions. In this case, the dimensions are Banker Thompson and the edition whatever format we are taking it. It has many to many relationships. In the join, you will see a duplicated version of the measure value, and it will take you to a higher value. But in this relationship, it is actually showing that the 5,559 is the total rating she got for all the editions. Editions can be different, but the book is same, right? So each rating for each edition is going to only one book. If you go with a join, each edition is considered as one row, and all this will be multiplied for each book, and you will see a higher value in that case. This is the meaning of resolve and replicate. Aggregations resolve to the measure's native level of detail, and measures are replicated across the lower level of details inside the WIS only. This is how relationship will save the duplicated version of the measure values. In the practical content, if you do a join over here, you will see a higher number because each edition, if you have one book and if it has different edition, each edition will be considered as one rating, and each rating will be multiplied according to the book. This will throw up a higher value, but in this it will resolve and replicate your measure values and give you a unique value without creating duplicates. So this is all about the 8 R's we have in the relationship semantics. We call it smart aggregations, contextual joins, and these are totally dependent upon your dimensions and measures. This can be difficult to first understand, but if you just work with all this relationships concept by doing with the practice, you will definitely use relationships more often than joins. Okay. So this is all about our 8 R's, right? Right now, we will see about some of the tips we can figure out whenever we are doing with relationships. Okay, the first tip, you have to know where you have an empty field and where you have an unmatched value. So unmatched values will always be nulls. These are two different concepts. So the records are included in all your previous books or all books with ratings as per retain all measures, right? To see all the books, we must add in a measure from the books table. Let's do that how it works. Okay. So we have author name and we have formatting. Okay, let's take out the totals to just remove. So we have a case scenario where we are seeing the author name and the edition of it and how many ratings it has, the book has, that means. So adding a count of book in this case scenario, let's take the book count. So the book count will show you the unmatched values. Adding count of books to the columns introduce you to so many people that doesn't have who has an unpublished book with no ratings. So let's take an example of Robert Milowski. He, an author who has an unpublished book and he doesn't have any ratings. To represent no ratings with zero, you can actually wrap it up the rating with a ZN function. This will show you that there is zero value. That means there is a zero rating over here and you can show this guy into your visualization. So it may be surprising that zeros do not appear. This is because the measure is not an unmatched null. This mark is only missing because there is a zero content. These are not considered as nulls. There is data because this guy doesn't have a book over there. If you just wrap up with your the rating with your ZN, this will throw up a zero over there and you can show them as well in the view. So this one is not showing up because it doesn't have a space, but okay, let's do this. Let's only see this guy. Let's take out the book and place it here. So the book will be in details and this guy. So if you see here, Robert Milowski will be shown as 0. This value is actually coming as 0, and this one will be telling us that okay, this guy has a book but he doesn't have any ratings. This is not an unmatched value. Unmatched values will always be nulls, and if there is a no I mean if that guy has no rating, that means he didn't get the rating at all. That means yes, that should be actually 0, but not an unmatched value. And in this case scenario, you can show the unmatched values as zeros by putting the second count. So this is all about the relationships concept. This can be heavy, this can be very new, but don't be scared of one relationships. Your relationships can be very handy whenever you're doing with the complex scenario versions. Relationships don't actually replace the previous versions of combining data like joins, unions, or blends. Rather, relationships are a new flexible way to bring data together from multiple data sources. The existing methods are not going anywhere and are still useful in specific scenarios. So you can actually think about how your data is going to fit together and what questions you want to answer, rather than how to combine the data or compensate from the data sources. There can be scenarios where each individual visualization have to have a different kind of join. Even the tables are same, but you might need a different kind of join where you want to use in this merging scenario. Instead of merging all the data, you can go with a relationship, and Tableau evaluates the relationships of the relevant fields and tables and use what kind of join should be there in that particular view. Those relationships are used to write queries with correct join types, correct aggregations, and handles the nulls very well. This will have no upfront join type, or they will have an automatic and context aware kind of relationships, and they can be so flexible when you're working with multi data models. And one more thing to remember about extracting this kind of relationships, extract data is now stored based upon the logical tables. So how many logical tables you have is how many tables you will be saving up to. If you have one logical table and if you have other logical table which has joins inside, it can be two tables only because the other one physical table will be considered as one entire logical container. So this is completely based and stored upon the logical tables number. And a minor thing to see is whenever you're working with the relationships, you will no longer see the number of records field whenever you are working with the normal kind of join types. You will get an automatic field called number of records. In this relationships in the logical tables, you will not see this number of records column, but every table includes a count of its records. So if you the name of that particular table, and there will be a bracket with that count. Like in this case scenario, we have award count, book count, checkouts count, etc. So in this relationships, you will not see the number of records, but you will see a count of all the records naming with the table. And if you want to view the data to one particular table, and if you go with the view data of any single table, this will only show in the view data window whenever the data sources contains multiple logical tables. The number of rows and data are listed at the name level of data, and it will show each table separately. Calculated fields are listed under the table with their originating field. Whatever field you are creating that calculation upon, they will be going and adding to that particular table. And also there can be a minute change in the data column order whenever you see the data in the view data window or export the data to a CSV format. The change in how column order is actually handled in the view data window, and it will support the relationships and the logical tables. So the order can be a slight difference. You can see a slight difference whenever you export it to the CSV format. If you are using the lower version of Tableau, and after 2020 version, you can see a slight difference of the order of the column whenever you export the data to the CSV. So this is all about our relationships concept, and for this week we kind of went through so many things and we have learned so many things about relationships. So this week's summaries up to what is a relationship and what is the difference between relationships and joins and blending, etc. And what is the difference between them and how the data actually flows whenever you kind of use different join models or blending models when compared to the relationships. We saw how the data model is, we saw the single data table, or we saw the multi-data table models and how they are used inside your relationships concept. So we also created the relationships and we saw what kind of types of relationships we have, like one to many to many, and many to one kind of relationships. We spoke about cardinality and referential integrity, which means cardinality is uniqueness and referential integrity is the matching up of records with the other data tables. We saw eight kinds of R's and we spoke about smart aggregations, contextual joins, what are this actually R's, what are these eight R's related to, and how these R's behave in the practical way, how they are going to bring up the data when you are using only dimensions or a measure and a dimension from different tables. What happens if you use a measure from a different table, and what happens when only dimensions from one table, etc. Like we spoke about different things Tableau does with this all smart aggregations and different kinds of art we have. So this is all about the relationships, and we are going to end this relationships concept here. And thank you so much.